is Mutugi Craig Motegi. I'm a rising senior in the Jomo Kenyatta Institute of Agriculture and Technology in Kenya. And this is the beginning of a 4-part series in which I'll tackle each of the 4 questions to my right on how to use the Vulkan SDK on Android to draw computer graphics. This is in line with my computer graphics unit, which its main goal is to make us, the students, understand how a computer is able to draw graphics, namely lines and shapes, on a computer screen. To the first question, it requires me as a student to draw a rectangle of a given color yellow of given coordinates. For the setup, there are some things that I have to put across. I'm using my phone as the emulator or the screen in which my result will be printed on. And also, there are some technical terms that I'll have to go through. Namely, number 1. In the hello.vk.h file is where the Vulkan SDK is called and is where most of your input changes will occur, so that the Vulkan SDK can read the data and also simulate the data. It contains power pipelines, buffers in which input data, and also points of rasterization to smooth and also anti-alias lines and graphics. To answer the first question, I used a topology list. I used a topology of triangles so that I'm able to use 2 triangles to simulate 1 rectangle. In the given topology list, you can see here in the line 1142, the VK primitive topology of triangle list. There are many topology lists in the Vulkan SDK, namely line topology, line list, there's the point, there's also the polygon list, point list. But for my interest, I decided to use 2 triangles to form 1 rectangle. This means in the shader.vat file, in which I'm going to input my given coordinates, I'll have 6 points in which 4 of those given points are similar, so that those triangles can be just a mere reflection of the other along their diagonals. Also, I have to also point out that the natural set of coordinates in the documentation or to the question paper on my right cannot be drawn naturally on a computer screen. That's why you have to normalize the points so that they can be drawn efficiently on the screen. That's why you see I've divided each point by the highest point, which is 80. After which I discovered that these points the figure itself was too small, so that I multiplied by 2. And the reason you see the x and y have a different dedicated number that has been minused from, the 1.6 enables me to shift the figure away from the edges of the screen along the x-axis, so that it can be in the middle, and the negative 1.2 does the same for the same figure, so that it can be in the middle of the screen along the y-axis. The colors take the RGB format, in which 1 is equals to 0, which mainly means red plus green is equals to yellow. And also, given that the array of the positions list is 6, I have to initialize in the Vulkan SDK or the Vulkan API calling file, which is a hello.vk.h, that I have a position list of 6 that needs it to process, which I can find it at line 594, which can say vertex count of 6. Instance count shows how many instances of the same diagram do I have. Normally, instance count starts from 0 to 1. What does that mean? The first point to be drawn is the point 0. The second point, point 1, as it tends towards n. And for the result of this question, it's this diagram that you can see simulated on my phone as the screen. You can see it has a background of yellow, a background of black, and a figure of yellow answering the given question. Thank you.